So now, question 4, we are given the lines of symmetry, which is y is equals to x plus 1 and y is equals to minus x minus 7. So these are the equations of the axis of symmetry. And we are given the standard form of equation for a hyperbola, which is f of x equals to minus 2 over x plus p plus q. So 4.1, we are asked to find or to show rather that p is equals to 4 and q is equals to minus 3. So what we need to note first is that when you draw your axis of symmetry for a hyperbola, for example, in this case, these equations. So if let's say, for example, this is our hyperbola and it lies in this quadrant and this quadrant, and this is the arrow. So which means now that there is a symmetry that divides this graph into two. So it goes in this direction. So this one is a decreasing equation, which is y is equals to minus x. And then there's another one that is increasing, which we say it's y is equals to plus x. So these are the equations, the standard equations for a hyperbola. So now in this case, we are given the equations and we want to another thing before I erase, what you need to note is that these two equations actually intersect at a certain point. So in this case, this is where they intersect, right? So therefore this means now that even the equations that we are given of the axis of symmetry, we need to equate them. So the equation y is equals to x plus 1 and y is equals to minus x minus 7. So you have to equate them because these symmetries are equal at a certain point. So it's going to be x plus 1 is equals to minus x minus 7. Transpose the x the other side, we have x plus x, transpose the one the other side, equals to minus 7 minus 1. We have 2x equals to minus 8. Divide by 2 both sides, we have x being equals to minus 4. So that is the x value, and then the y value, so it's y is equals to minus 4 plus 1. We're using this equation here, which is y is equals to x plus 1. You can use either this one or this one. So x is minus 4, which is what we just found, and the plus 1, then you can have minus 3. So y is equals to minus 3. Then using the standard equation, which is f of x equals to minus 2 over x, remembering that x is equals to minus 4, but you need to take it, so it's x equals to minus 4. Taking it to the other side, it's x plus 4 equals to 0. So we're gonna write x plus 4 here, and then our y is equals to minus 3, so we're gonna write minus 3. So this is the standard form of equation, but we are asked to find the value of p and q. So this is the value of p here, which p is equals to 4, and this is the value of q here, which q is equals to minus 3. Now the second part of the question, 4.2, says that we must calculate the x-intercept of f of x. So basically that means we need to equate y as 0. Okay. Oh boy. Fine. So we're having f of x being equals to minus 2 over x plus 4 minus 3, and we are asked to find the value of x, the x-intercept of the graph. Y has to be 0, so it's minus 2 over x plus 4 minus 3. Then you transpose the minus 3 to the other side, we will have 3 equals to minus 2 over x plus 4. Then we do a cross multiplication. It's going to be 3 into x plus 4 equals to minus 2. Then we divide by 3 both sides. We will have x plus 4 equals to minus 2 over 3. Transpose the 4 to the other side. X equals to minus 2 over 3 minus 4. So you add both, you should have minus 14 over 3. So that is the x-intercept of the graph. So now 4.3 we are asked to draw the function of the hyperbola showing all x-intercepts and the y-intercepts and asymptotes. So the x-intercept that we just found here, when y is equals to 0, the coordinates is minus 14 over 3 and 0. And finding the y-intercept, when x equals to 0, we know our f of x is equals to minus 2 over x plus 4 minus 3. So to find the y-intercept, we need to equate x as 0. So it's minus 3, and what you need to find is minus 7 over 2, which is approximately minus 3.5. So that is our y-intercept, minus 3.5. Cool. So now that we know our intercepts, we can draw our graph. So let me write the intercepts here. We have minus 14 over 3 and 0. We also have 0 and minus 7 over 2. And we also know our asymptotes, right? If f of x equals to minus 2 over x plus 4 minus 3, so meaning our vertical asymptote, it's x v is equals to minus 4. Our horizontal asymptote, y horizontal, is equals to minus 3. Cool. So if we draw our function, and before you even start, we need to know the shape of the function. So how do we identify the shape of the function is by looking at the value of a, which is minus 2, this one here. So if a is less than 0, then the graph lies in the second quadrant and the fourth quadrant. So by first writing our asymptote, which is x equals to x being equals to minus 4 and the y being equals to minus 3, and our intercepts, this one here, minus 14 over 3 is somewhere here, which making the graph look like that, and then minus 7 over 2 is somewhere here, which will make the graph look like that. So this would be your graph of the hyperbola, indicating the coordinates for this point here, which is minus 14 over 3 and 0, and coordinates here, which is 0 and minus 7 over 2.